Again, welcome to College Algebra. In this lectures, we're going to discuss about how to write equation of parallel and also perpendicular lines. If two lines are parallel, we know their slope is the same. If two lines are perpendicular, it means the slope of one line is negative reciprocal of the second line. Also, we're going to learn how to use linear curve fitting to solve problems. Most of this problem will be on linear models. So our main objective is to write equations of parallel and perpendicular lines. Also write an equation of a line that models a real life problems. And this will be a linear, again, models, which is a straight lines. Then we're also going to use linear curve fitting to solve problems. So we start with to write equations of parallel and perpendicular lines. And we have an example here. In this example, they say we should find an equation of a line, pass it through a point, and the point have x coordinate is -2 and y is 5. So again, this is two-dimension plane. We have x and y, -2 and 5. And it's parallel to the line y equal to 8x minus 3. So now to write an equation of a line that passes through the point given and is parallel to a second line given, what we need to do first is to find the second line slope. Since we know the second line equation is given to be y equal to 8x minus 3, the slope will be 8. Now, if two lines are parallel, it means the slope are the same. So the second line also slope will be 8. Now we know the x and y, the point. So here we can use the slope formula to write our equation. So let's go through the steps. Here we say we're going to substitute the coordinate of P, which is -2 and 5, and also the slope of the line parallel to y equal to 8x minus 3. So since the second line, as we said, is 8x minus 3, the slope is 8. So we said the slope of the line given by y equal to 8x minus 3 is 8. That's the coefficient of x. Now, since the graph of the desired equation is parallel to the line of the graph of y equal to 8x minus 3, then we say the second line is also slope is 8. Well, the question says find an equation for a line passing through a point and is parallel to the line y equal to 8x minus 3. So if the y equal to 8x minus 3 slope is 8, then the second line slope also is 8 because they are parallel. So what we do next, we substitute -2 for x and also 5 for y. And we know the slope to be 8. So we use the point slope form. Again, this is what we discussed in our previous lectures. The point slope form will be y equal to y minus y1 equal to m times s minus s1. The point slope formula came from the slope formula because we know slope is equal to y minus y1 over s minus s1, or s2 minus s1, then the numerator will be y2 minus y1. So we know y1, we know s1, we know m. So we substitute for our y is +5. Our x1 is -2. So we get y minus 5 equal to 8. Negative times negative is positive, so we get +2. Then y minus 5 equal to 8 times x will give us 8x. 8 times 2 will give us 16. So we are going to take the -5 to the right side of the equal sign, so it will be +5. So 16 plus 5 will give us 21. So this means our line equation will be y, that's the second line equation, will be y equal to 8x plus 21. Again, both lines have the same slope value 8 because the two lines are parallel according to the question. So we can summarize various forms of equation of a line as following. So we know the standard form of our equation always is A and B and C can be any value. But again, A and B cannot be 0, because if A and B is 0, we are going to miss the X and Y variables. We need the X and Y. But C can be any value. It can also be 0. So the standard form, AX plus BY equal to 6. So A and B cannot be, again, cannot both be 0. Now we know the slope-intercept form will be Y equal to MS plus B. M is our slope, B is our Y-intercept. Y-intercept means when S equal to 0, the value of Y. We just use the point slope form to find an equation. Always, most of the time, we use the point slope form to find an equation of a second line where the first line is given. Either is para, the second line is para to the first line, or perpendicular to the first line. Also, anytime we have a line that is horizontal, it means the X coefficient is 0, so we don't have no X. So if I have Y equal to B, the line will be horizontal. The line also will be vertical if S equal to A. But here we say there's no defined slope. What we're trying to say is that when a line is vertical, there's no slope value. There's no defined slope, because we know slope is the difference of Y divided by difference of X. When a vertical line means the X values are the same. S1 is the same as S2. So any value divided by 0 is undefined. So in this case, we're going to get two different Y value, but the S2 minus S1, they are the same value, so it will be 0. Now let's go to the second example. Write an equation of a line that models a real life problem. So in this case, this question is based on a business application. Here we say a business purchases a digital multimedia projector for 1970 or $1,070, and it's expected to last for 10 years. It can be sold as a scrap for the salvage value of $270. So this means we buy a projector $1,970. In 10 years' time, we can sell it for $270. Now, if Y is the value of the projector after X years, so our time will be X. Y and S are related by the equation of a line, because again, the number of years will determine the price of the projector. As the years increase, the price of the projector goes down. So this will be a decreasing relationship, which means our slope value will be negative. Now, the first question says we should find an equation of the line. Then when we get the equation of the line, we're going to find the value of the projector after 2.5 years. So this means, remember, X is our years. So when we get the equation of the line, we are going to substitute X with 2.5 years, and we can find the value after 2.5 years. Then find the economic meaning of the Y-intercept of the line. Y-intercept means when S equal to 0. So that will be the brand new, when we buy it newly, and there's no years yet, it's new. And the answer should be 1970. Also, find the economic meaning of the slope of the line. So let's start with A. We will find the slope and use the point slope form to write the equation of the line. So here we know we have, again, as we said earlier, we bought a brand new projector to be $1,970. So since it's new, that will be our Y-intercept. So we can see that X equal to 0. This will be in years. We know that in 10 years, we can sell it for $270. So at least we have 2 points here now. We have 1 point when S is 10, Y is 270. That's when, based on the question, in 10 years that we can sell it for 270. We bought it brand new, so the number of years is 0, and the price was 1970. So with these 2 points now, we can find the slope. So the slope is Y2 minus Y1 divided by S2 minus S1. Y2 is $270, the price we are going to sell after 10 years. Y1 will be our new price, 1970. So S2 will be 10. 10 give us 270. And when we bought it brand new, the years is 0. So we have 270 minus 1970 and 10 minus 0. So our answer will be negative. As we said earlier, the slope surely will be negative because as the number of years increase, the price of the projector will go down. So that's why the slope is a decreasing value, negative value. So if we know the slope now, we can take any of these 2 points, 10 and 270 or 0 and 1970. Then we use the point slope to substitute. So here we decided to take 1970 and 0. Again, we can take 10 and 270, we get the same answer. So we have y minus y1, the slope s minus s1. So y minus y1 is 1970. The slope is negative 170, s minus 0. So when we simplify this equation, we get y equal to minus 170x plus 1970. Because 1970 is negative. When you cross the equal sign, it's going to be plus. Plus 1970 minus 0 is plus 1970. So this means the value of the projector is related to its age x by the equation y equal to minus 170s plus 1970. So now if we want to find the price of the projector after 2.5 years, we just substitute 2.5 in the equation. So B, find the value of the projector after 2.5 years. So we're going to substitute 2.5 for x in the equation. Then we solve for y. So here we get y equal to negative 170s plus 1970. S is 2.5. So negative 170 times 2.5 will give us negative 425 plus 1970. We find the difference of the two. We get 1545. So this means after 2.5 years, the projector will cost $1,545. Then we can go to C. C said we should find the y-intercept of the graph. We already know the y-intercept of the graph, which is 1970. Because when x equal to 0, when we bought it newly, it's 1970. But still we can, again, plug in the values. We have y equal to minus 170s plus 1970. X will be 0 plus 1970. So y will give us 1970. So this will be the original price when s equal to 0. Indeed, they say each year the value decreases by 170 because that's the slope. The slope, because the slope of the line is negative 170, so it's decreased. So the slope of the depreciation line is called the annual depreciation rate. Now, next, we're going to use the linear curve fitting to solve problems. So we know in statistics, we have the concept of regression. Regression, that is the process of using one variable to predict another variable. Now, sometimes in order for us to use one variable to predict another variable, we are going to find the correlation coefficient so that we can find out if there's any association between the two variables. Normally, the variable we are going to use to predict the other variable is called the independent variable. And the predicted variable will be called dependent. So example will be the x and y. X is our horizontal line, y is our vertical line. So our x, normally the horizontal line will be our input or independent variable. And we can use it to predict the output, which is the dependent variable or the y. So for example, if we know a woman's height, we can make a good prediction about her weight because the taller women usually weigh more than shorter women. This will be based on the data given. So doing regression, we need the data to find the pattern in the data. So to write a prediction equation, sometimes called the regression equation, we must find the equation of the line that comes closest to all the points. This is called the best fit line. So we may have points. If all the points fit in a straight line, that means we have a very strong correlation or association between the two variables. So even the correlation coefficient will be 1. If it's increasing, it's 1. If decreasing, it will be -1. So this is again statistics concept models for regression. The same thing we are applying here, because here we have a linear line. So linear line again is what we are doing in college algebra. In statistics also the same concept, but in college algebra we are assuming all the points are on the line, or the previous example we did. So if I want to find the slope, I'll just take any 2 points on the line. But in the real world, all the points cannot be on the same line. So in this case, if I want to find the slope of this line, best fit line, I cannot just take 2 points on the line, because each point around the line or close to the line have effect on the best fit line. So there's a special formula we have to use. So here we say the figures show the rest of the sample 10 women. So these are 10 women, and finding their weights and their height. Here we can say that even it's not perfect increasing relationship, but we still can see the pattern that is an increasing relationship. So here we say write an approximation of the regression equation. Then we can use the regression equation to approximate the weight of a woman who is 66 inches tall. So the height is our independent variable. So when we know the height, we can predict the weight. So here we plot the equation. And here we say that in the figure, line PQ is drawn, and the point P has a coordinate of 60 and 100. Q has a coordinate of 67 and 155. So we can see the P and Q. So we find the slope, which gives us 55/7. Then we find the point slope. And we use the point slope to find the equation of the line, the regression line. And based on that, again, we substitute the x1, y1, which is 60 and 100. The slope we just find to be 55/7. And this is our regression. Again, here we are doing college algebra, but in statistics, we have to consider all the points around. So there's a special formula we have to use. Here we're still taking the 2 possible points on the line. 60 and 100, then 67 and 55. So that's what we use to find the slope. 155 minus 100, 67 minus 60, those 2 points on the line. And then we use the point slope. In statistics, we don't use, there's a formula we have to use, not a point slope. And there's a formula to find the slope. And this again, college algebra. So we use the point slope to find the equation as the previous example. Now we know the model. So the next question B said, what would be the weight of a woman who is 66 inches? So anywhere I see X, I'm going to substitute with 66. So this is our model again, the regression equation. So we substitute 66. 66 inches gave me 147.14 pounds. So again, this will be the conclusion of our lectures on a linear function. So in this section, again, we learn about linear functions, how to find the equation of a second line if we know the first line is either parallel or perpendicular. And I think we went through this also in the previous lectures. The new thing we learned here is how to apply business applications to solve problems, like use the linear curve fitting to solve the problems. So again, wish everybody the best and thank you.